Hey everyone, let's look up at the sun during the day. It's a sight we often take for granted, but there's so much more to it than meets the eye. It's bright, right? The sun, our very own star, has been giving us light and heat for a very, very long time. For billions of years, it has been the center of our solar system, providing the energy necessary for life on Earth. But have you ever wondered where it gets all that energy from? It's a process called fusion that happens deep inside the sun. Fusion is an incredible phenomenon where the sun's immense gravity and pressure force hydrogen atoms to collide and merge. Imagine a place so hot and squished that even atoms behave differently. That's the sun's core. Temperatures here soar to millions of degrees, creating an environment where fusion can occur. There, tiny particles called hydrogen atoms combine to form helium, releasing a tremendous amount of energy. This energy is what powers the sun, and in turn, provides us with the light and warmth we experience every day. It's like a giant energy factory. This energy travels all the way to Earth as sunlight. Without it, our planet would be a cold, dark place, unable to sustain life as we know it. So next time you feel the sun's warmth, remember the incredible journey its energy has taken to reach you. Fusion is like the engine that powers all stars, including our sun. It's a process where light atomic nuclei combine to form a heavier nucleus, releasing energy in the process. This energy is what makes stars shine so brightly and sustain their immense heat and light for billions of years. It's different from how we make energy here on Earth. On Earth, we rely on burning fossil fuels, harnessing wind, or capturing sunlight to generate power. These methods are effective but fundamentally different from the fusion process happening in stars. Fusion uses special types of hydrogen atoms called deuterium and tritium, which combine to form helium and release a massive amount of energy. This reaction is incredibly efficient and produces much more energy than traditional chemical reactions like burning coal or gas. Imagine the energy from a tiny firecracker compared to a giant fireworks show. That's the difference between fusion and other energy sources. The energy released in fusion is millions of times greater than that from chemical reactions, making it a powerful potential source of energy. But fusion needs a super hot and squished environment to work, just like inside the sun. The core of the sun reaches temperatures of around 15 million degrees Celsius, creating the perfect conditions for fusion to occur. This makes it a bit tricky to recreate on Earth. Scientists are working on creating these extreme conditions in laboratories and reactors, but it's a challenging task. If successful, it could revolutionize how we generate energy, providing a nearly limitless and clean energy source for the future. Creating a mini-sun on Earth is a huge challenge. Imagine trying to replicate the core of a star right here on our planet. It's an endeavor that requires immense precision and cutting-edge technology. We're talking about temperatures hotter than the sun's surface. These temperatures can reach millions of degrees, far beyond what any material on Earth can withstand. At such high temperatures, everything turns into something called plasma, which is like a super hot soup of particles. This plasma is the fourth state of matter, distinct from solids, liquids, and gases. And this plasma is tough to handle because it can't touch anything without cooling down. If it loses heat, the fusion process stops, making containment a critical challenge. Scientists are like chefs trying to cook this plasma soup without a pot. They need to keep it hot and contained without letting it touch the sides. They're using powerful magnets to hold and heat it. These magnets create magnetic fields that can trap the plasma, keeping it suspended in midair. It's like trying to hold a beach ball underwater. It wants to escape. The plasma constantly tries to break free, making the task incredibly difficult. But don't worry, scientists are getting closer to making fusion power a reality. With each experiment, they learn more and get one step closer to harnessing the power of the stars for clean, limitless energy. Scientists are exploring two main ways to achieve fusion: magnetic confinement and inertial confinement. Imagine trying to squeeze a balloon without popping it. Magnetic confinement uses strong magnets to gently squeeze and hold the hot plasma like an invisible hand. Inertial confinement, on the other hand, uses powerful lasers to quickly heat and squeeze a tiny target, like popping a tiny balloon filled with fusion fuel. Both methods have their own hurdles, but scientists are making great strides. Fusion power holds the key to a cleaner and more sustainable future. It's like switching from polluting coal to clean solar energy, but on a much grander scale. While challenges remain, scientists and engineers are working tirelessly to make fusion power a reality. It's like a giant puzzle, and each breakthrough brings us closer to the solution. Fusion power is not just a dream, it's a journey toward a brighter future for everyone.